Hello, Matthews Gatos here. Welcome to this video on representing relations and interpreting and sketching graphs. Let's begin with just a little bit of terminology. So first thing I need to talk about is what is a set. A set is just a collection of different items. We denote a set with these squiggle brackets like that. So everything inside of that is the entire set. For example, 0, 1, 2, 3, 4, etc. is the set of whole numbers. Now what's in the brackets, these things here, are called elements. So element is just one object within the set. Now we denote that with a little e. E for element. So for example, 2 is an element of the whole numbers because it was one of the objects in the set. Now, since we're talking about relations, we should probably talk about what a relation is. A relation just shows how two or more sets are related to one another. Now, we can represent relations in 5 different ways. We can use a table of values, ordered pairs or coordinates, a graph, an arrow diagram, and the most common way of representing a relation is with an equation. So I just want to look at an example starting with a graph and looking at how to express that relation using coordinates, table of values, and an arrow diagram. So we have this relationship between elements in the set of X and elements in the set of Y. Put them together and they are coordinates. So let's just list out what the coordinates are. In no particular order, I just like to read my graph from left to right. I would start with this point here, which has coordinates of -2 and -4. This point here, coordinates -1, -2. This point here, coordinates of 0 and 0. Here we have a coordinate of 1 and 2. And here we have a coordinate of 2 and 4. So the graph shows the relationship between elements in a set X and elements in a set Y. We can also represent that with coordinates. Let's look at another way. We could use a table of values. So we could list all of our X values, which was -2, -1, 0, 1, and 2. I like to put those in order from small to big. And then the corresponding Y that goes with them, -4, -2, 0, 2, and 4. So try and organize in your table of values your X values going from small to big and make sure you match it up with the correct Y value. So that also shows the relation. We can also use an arrow diagram. So I'm going to write down all of my X values and I'm going to show how they map over. So -2 goes with -4, -1 goes with -2, 0 goes with 0, 1 goes with 2, and 2 goes with 4. So I can actually say that this relation is a 1-to-1 relation. What I mean by that is all of the elements in set X map directly to only one element in set Y. So that's a 1-to-1 relation. So now that we've talked about different ways of expressing a relation, let's look at graphing a little bit more closely. So in this example here, we have each day several leaves falling from a tree. One day a gust of wind blows off many leaves, and eventually there's no more leaves left on the tree. Which graph represents this situation? So you can see in this graph here, we're looking at the number of leaves in the tree versus time. So let's see, we have leaves that are falling from the tree. So we start with some leaves and then they start to fall from the tree. So this one here shows that the number of leaves is increasing. That doesn't make any sense. So I know it's not graph A. So graph B and C both show that the leaves are decreasing. Okay, and then a gust of wind comes along and blows off many of the leaves. So this shows that they decrease quite quickly and then they slowly start to decrease here. So does that represent the relation, or is this one here? So we have some leaves falling, nothing happens, and then they rapidly decline until there's no more leaves on the tree. I think in this situation here, graph C represents it because we have the leaves falling from the tree and then nothing happens, and then a gust of wind comes and blows off the rest of the trees. Graph B shows that they're constantly decreasing. So decreasing and then decreasing and then decreasing. So I think graph C more accurately represents that graph. Now, a common way of representing relations is with distance time graphs. Now, when we have that, it talks about the motion of an object. We always put time on the horizontal or x-axis. As we read from left to right, that means that time is increasing. Now, distance is always plotted on the vertical axis, the y-axis, and that goes from 0 upwards. So the higher up on the graph, the further the distance from the start. A couple of things to mention about distance time graphs. When the object is not moving, that means that time keeps increasing, but notice the distance does not. It stays at the same spot. So it is a horizontal line. So when I have a distance time graph, if I have a horizontal line, that means the object's not moving. Constant speed. If I have time increasing and distance increasing at a line, it is increasing at a constant amount. So as time increases, distance increases, and they are proportional to one another. That's represented with a straight line. Now, the higher the speed, the steeper the line. So I have a solid and a dotted line there, and I can see that the steeper line is the dotted line because time is still increasing, but distance increases at a faster rate. So both lines are straight, both lines are constant, but the higher speed one is the steeper graph. So let's put that together in our last example here, looking at Teo going on a bike ride. And I want to describe each section of the ride. So in this graph, I see 1, 2, 3, 4, 5 sections that I need to talk about. So in my first section here, I see that time goes from 0 to 20 minutes. So in 20 minutes, on his bike ride, Teo goes from 0 to 3 kilometers. So 20 minutes he rides and he covers a distance of 3 kilometers. In my second section here, I am not covering any distance. I'm still just staying at 3, but time keeps on going from 20 to 30. So in this section here, I would say that he took a 10-minute rest. Okay, in section number 3, so that's a steeper section than the first one. So it looks like he's going a little bit faster. Let's see. So from 30 to 40, that's 10 minutes. He covers a distance of 3 to 5. He covers a distance of 2 kilometers. So the time is half, but you can see the distance is not half. So he's definitely going faster than section number 1. Okay, now section number 4 again is a horizontal line. Distance is not moving, but time is. So it looks like he's taking quite a bit of a longer break. So for 40 minutes to 90 minutes, he's not riding his bike. So for 50 minutes, he is not riding his bike. He might be resting, maybe he's at a store shopping, okay? And then I can see I have a very steep section here. So he's probably like, uh-oh, I need to get back where I started, and I need to do that in a hurry. So 90 to 120, that is a distance of 30 minutes, and let's see how much he covers. He covers his distance of 5 kilometers all the way back to 0, means that he covers 5 kilometers. So knowing how to interpret a graph is very important. It's a very important part of relations. So we've seen to represent relations with table of values, coordinates, arrow diagram, and graphing. We'll get to equations a little bit later in the chapter. So that's the end of our video. I hope this video helped. If the video did help, I recommend that you give it a thumbs up and hit subscribe so I can help more mathies just like you. Thanks for watching. See you for the next one.